Hi guys, this is my new pulse motor build. Sorry it's taken a short while to post a new video. Just been looking for work and just been waiting on some cash so I can just complete this. I'll explain the construction details. You have two rotors. Each of these magnets are rated as N52. They are 20mm by 10mm thick, triple stacked, and you got 12 on each rotor. Turn it on without me even explaining the construction. Alright, just stop that for a minute. Same thing with this rotor, that one's the same as that. This design to begin with is supposed to be intended as a magnetically geared pulse motor, which did work, but the cogging of having these hex bolts here to act as a flux modulator and the timing of that, there was a bit of an issue during that time. But funny enough, after I whipped up this new arrangement, I figured out the problem. So maybe in the future, I can give that a crack. So I've removed the hex bolts here. That was intended to be a flux modulator. So as you turn one, you get 3 times to turn out. And I've just made it as a pickup coil instead between these two. Now these are 30 AWG size wire, rated about 110 ohms each. And it's wounded in the serpentine coil. It's hard to kind of see because it's all quite tight. And instead of using it for the original idea, I just now intended that as a pickup coil generator instead. You got that fat size magnet here, which is 40mm wide by 20mm thick, and there's 4 of that, and you got 12 of that. As you guessed it, you know, it gives me a 3:1 ratio of the turn at that time. But now it's just a rotor that spins independently and it rotates in the same direction. You have 3 zirconium ceramic bearings that's positioned here. One inside the rotor there, and another one on top there to hold it, to run it smoothly. And it's kind of coupled in the center of the shaft, which is a sleeve that's kind of positioning it in place. You have this fat coil here, which is an 18 gauge size thick wire in about 40 ohms. I didn't count the turns, I just rounded it until I got my desired length. You can use a calculator online to give you the desired length that you need. I didn't really do that, I just counted it because I'm kind of used to it. And only one of these coils are hooked up so far. I've got another one here that's unhooked. And I've also got these 2 over here, which are 24 gauge size wire with soft iron core, which I'll be trying in the near future. It's going to be charging this Maxwell Ultracapacitor 2.7 by 350 Farads, which in total is 16.6 Farads. And that's just a multimeter that's connected to that, that's been previously charged. This is a driver circuit which has been designed by Wind Power More. He's got some fantastic videos on how to build it. So if you want to know the schematic and how to do it, just jump on his channel and there's a 3-part video that explains it. It's fantastic. It's very diverse. If you know what you're doing, there's many ways you can run this. And while this power supply that's set on 24 volts, it'll be charging that, and it's going to be running that 100 watt 24 volt DC scooter motor. So while it's running that motor, I'm able to climb that charge at the same time. And you'll see the amperage draw, it's about 0.2 to 0.3 amp draw. So, you know, anywhere from 7 and 8 watts between there, give or take. And yeah, let's give this baby a crack. There she runs. The one below it all starting to turn as well, because you've got two magnets here that's coupled to each other. There's a lot of vibration going on. They will steady as it picks up its momentum. There's the charge. So really good considering the amps that's thrown out. As you know, volts are not real power, it's the amps. But you want to use the electromotive force as your favour as well. That way you've got this efficient machine driving the loads. Now, try to do this with one hand. I'm going to connect this 100 watt DC motor to it. Maybe I have to just fucking run off it a bit, just 1 second. There we go. Let's run the motor. Got 2 rotors running. And this should climb. On my first observation, it should climb. There we go. As long as that ultracapacitor gets charged, that will run faster. And then the current will just steady itself, and it will go to a point where, you know, it will drop to a point where it's steady eddy. Now, the next step will be is I've got this idea where you got this coil, as you know, you got this one driver circuit that's going to be charging that, and then once that gets charged, it's going to run another driver circuit which is going to get positioned here, and it's also going to charge another capacitor. And the point is, it acts like a dynode, you know what I mean? It's like it increases the RPM and the torque without affecting the input, and that's what you want if you want to rely on these as pickup generators, because they are frequency dependent. And then once you have your second ultracapacitor going, then you can run your desired load while having a self-looping mechanism with these pickup coils. Or in reverse, you can use the second ultracapacitor bank to self-loop it, and you can use these pickup coil generators to run your load. At the moment, I'm just going to find what would be the solution to that. I thought I'll give you guys a show just to see where I'm at. I'm very happy with the results already. This is without any fine tuning or adjusting. I just ran it for the second time because the first time was quite turbulent, the shit was shaking, and now it's all tightened and it's running quite smooth. On my next video I'll be showing you some other components that also arrived. They are quite interesting. I'll explain in full detail on the next video and what will be the next step on that. There's our clients, they will get quicker. It's pretty fucking decent for a second run. Just to show you in the full scope where it's at. I will be using the scope shot in the next video. We'll get into the nitty-gritty details and how efficient it is. It can run on 12 volts, however though, the capacitor will be struggling to keep itself charging while that's running. I figured out a way also to overcome that. So, when there is a will, there is a way, mate. Well, I think that's pretty much it. If you got any questions, please leave it below in the comments. Thank you very much for watching.